Welcome to Modelling Showdown. So, got a feedback slide up at the beginning. We'll show it again at the end. But just to remind you that if you submit feedback, you get entered into a prize draw. And the best prize of all is the gift of feedback, so you can be awesome and you can help me improve at the same time. Oop, it's not working. Right. So, hi, I'm East. I'm the head of analytics at Advancing Analytics. I started my data career as an analyst, and before that, I became a business intelligence consultant, and I just progressed from there. As you've noticed, I do have a very unusual name. Many people get it wrong, and that is absolutely okay. If you remember the compass direction, you'll always get it right. So, I'm originally from the southwest of England, spent over a decade in London, and now I live in France. These different experiences have helped me apply a way of thinking differently about very familiar things. I love talking about analytics, sharing ideas, and helping everyone get better at it. When I started my career in data, I wasn't familiar with data modeling at all. And some of the early pieces demonstrated that lack of ability quite clearly. But what helped me was being introduced to data modeling by a couple of people called Jeremy and Neil. So some of that experience has been shaped by them and their experience. So before we go on, a bit of housekeeping. Questions kept to the end, but there is also going to be opportunities for audience participation. But if you do heckle, there is a possibility that you might be invited onto stage. So the pace of change that we've been experiencing often feels like everything is happening everywhere, all at once. And as a result, data modeling has fallen out of favor. And that's largely because the technology in the early days of big data didn't really support it, or the people behind it didn't really care. So it got forgotten about. But everyone has now been reminded of data modeling with the advent of things like data mesh and concepts of data as a product. The reality is, technology changes all the time, but some things remain eternal. One of those eternal things is data modeling. A lakehouse is a warehouse on a different technology stack. The patterns and principles are the same. How you do it is going to be different. We've already seen earlier in the keynote the embedding of copilots pretty much in everything. But effective copilots require great data modeling as well as good metadata. So I've always found modeling to be important, and if done well, helps solve a lot of problems that businesses encounter in general. So, a bit of audience participation. Shout out if you have any ideas. What is a data model? Anyone? Collection of data with relationships, yep. Anyone else? Any advances? Okay. Ultimately, it's a blueprint for a system, used for operational systems as well as analytical ones. Show of hands. Who's worked with operational systems with a terrible data model or an apparently non-existent one? Everyone, awesome. But a data model, other than a collection of data and relationships or a blueprint for a system, also represents a business process and is best described using nouns and verbs. So with nouns and verbs, we can express our business processes, the events within, with each noun having a series of objectives to distinguish itself from other nouns. We use basic grammar to describe a model so that they can be easily understood by a wide audience. So we have customer buys a product, employee orders stock, company manufactures a product. Technical terms like entities, facts, dimensions, links, hubs, etc., just generally cause a lot of confusion outside of technical audiences. Can create a lot of confusion because there's also different understandings about what those concepts can mean. I've been asked a few times, are all models equal? So things like when we're trying to define a data model, is it a warehouse? Is it a data mart? Is it a fact table? Is it the semantic model? The answer is yes. They're all a model, just different types of granularity of detail for that model. So let's use a very, very, very tenuous analogy, designing an apartment building. The overall building has a design, like a warehouse does. Each individual unit also has a design, kind of like our facts and dimensions. And each apartment unit will have shared facilities, like we might want to share dimensionality like dates. So they are all one and the same, yet they're different at the same time. So we've got 4 different perspectives to consider when we come to modeling: our user, the concepts, logical and physical. So our user model is going to be the most widely recognized format. It is a table. It is used in pretty much everything, from databases to desktop software applications like Excel, our friend. It's highly accessible. It's used by everyone. It's used by accountants to do payroll. It's used by resource managers and HR to do HR stuff. The weakness of this format is that it's not very readable, it's not very friendly, and it's not very easy to make quick decisions. So we can enhance our user model, slapping some charts on over the top. It increases and improves readability, which is often missing from those earlier tabular formats. Our physical model is a technical tool. It underpins the data model. In this example, we're using the dimensional model, where the physical model defines how that database is actually built. It documents factors like relationships, keys, and data types. As such, this model is very much a tool for data professionals and developers rather than for a general audience. A logical model is that happy middle ground between a user model and a physical one. It starts thinking about our entities in a business event and how to link them without getting overly bogged down in the technical details of how things connect. But before we get to any of that, we start out with a conceptual model. A conceptual model is needed to define business terminology, processes, and rules that get applied to data. Any ideas as to why we might do a conceptual model? Okay. It's so that we can agree on definitions of concepts. Concepts like customer, or product, or a train. What is a train? Anyone want to make a guess as to what a train is? A vehicle that brings you from A to B. Yep. Made up of rolling stock. But is that a train, or is that an asset? Or is it a scheduled item like the 1209 from Gare du Nord to St. Pancras? Or is it a specific scheduled item like today's one? Or is it just something that marketing dreams up? So defining and agreeing what these concepts mean to us allow us to move on with what our train means in our context. Right, who's a fan of Westerns? I'm a fan of Westerns. Yeah, not many people. Cool. Right, this is going to be very tenuous for those of you who don't like Westerns. So we have our data vault. Our data vault is a data modeling approach and methodology for building, so the marketing says, a scalable and adaptable data warehouse. And it does this through applying very generic principles and contain 3 core types of tables: hubs, which contain business keys; links, which define the relationships between those hubs; and satellites for storing any historical data changes. Supports incremental data loading, is great at loading data fast, simplifies integration between multiple sources, and provides a flexible foundation for future data analytics. Conceptually, it's great at conforming concepts. from multiple systems. However, if we have a look at this example data vault model, it is pretty ugly. In the red, we have our links. In yellow, we have our satellites. And in blue, we have our hubs. And if we were to throw analytics directly over this, what do we think would happen? Give people a couple of seconds to think about it. What do you think would happen if we tried to query this? Might not perform beautifully. You'd be correct. So we get SQL queries with lots of joins that wouldn't be performant without heavy indexing. And those heavy indexing then defeats the purpose of data vault because it's meant to be write performant rather than necessarily re-performant. Next we have graph. Consists of nodes and edges, and those edges represent the connections between nodes. So nodes in a graph represent different entities, different objects, and as mentioned, the edges represent the connections and interactions between them. Commonly used for modeling complex relationships like social networks, recommendation systems, road networks, even like data flows, best described in a graph. Visually, graphs are great, love them. Querying them can be a little challenging, particularly if you come from a very relational background, they behave differently. But saying that, once you've got your head around graph, they're quite easy. Right, dimensional. This is probably the most commonly used form of data warehousing in data warehousing and BI applications everywhere. It consists of a central fact table, so different values and metrics and measures, and multiple dimension tables, which contain the context for why these events exist. And that's all connected to the fact table via foreign keys. There are two very similar dimensional model types, the snow and starflake schema. The star and snowflake schema. The star is basically the most commonly used one, particularly if you're in the Microsoft world. And it simplifies data analysis by denormalizing data, reduces the number of joins required for analysis, resulting in faster query performance. Snowflake is effectively an extension of the star schema, where dimension tables are further normalized into subdimensional tables. Benefits of this is that you reduce data redundancy, you can improve data integrity, but then the flip side is that it requires a more complex query structure. Done well, dimensional models are fantastic. Not done so well, they're awful. Criticism of dimensional models include inability or difficulty in adapting them, and also developing them iteratively. We'll have a look a little later on as to how you might want to do that and approach it in a more iterative manner. There are also different approaches, so Inman versus Kimball, which need to be considered, and they've traditionally defined how designs of a data model happen. So Inman, the father of the data warehouse, coined the term in 1989, favors a top-down approach, so focusing on the data rather than any business processes to inform that design. Kimball, on the other hand, kind of takes a bottom-up approach, taking the business process, taking the value-led approach to defining how we design our dimensional model. So entity-centric is a rich, wide table focusing on a specific entity concept, like a user, product, customer. It simplifies analysis by having all those different metrics that might be associated with an entity on that actual entity. So it minimizes the need for joins. It applies a feature mindset. So if you're in a data science machine learning environment, entity-centric is kind of like your friend here. So it starts thinking more about how we actually do things like classification, segmentation. What it looks like is something like this. So it's quite aggregated, and it's great for its intended use case. However, it can introduce complexities when managing relationships because it abstracts those relationships. also introduces rigidity in the schema because you've aggregated things. So if we want to change things, we need to do a full reload of that data. Finally, one big table, also known as a flat or denormalized model. And it's just an alternative approach to data organization where it is stored in one big table. Simplifies data access, simplifies querying, particularly for analytics which might involve full table scans, but it lacks structural benefits and flexibility of a more normalized model in certain scenarios. You optimize it for a given query. So if you are focusing on customer sales, you create a query which focuses just on that, and that is your one big table. And you do this because storage is cheap. So super simple, storage is cheap, but compute, on the other hand, is not. So if you have our customers, if you have our products and our orders, we have one big table. So each time you hit one big table through a BI application, well, let's just say that BI applications aren't necessarily the most efficient at writing performance queries. And what is simple in terms of storage is very costly when it comes to querying. Like our entity-centric approach, managing relationships can be challenging. So we've got the different modeling approaches. There's lots and lots of different features and where they kind of tick the boxes. And dimensional model appears to tick the majority of the boxes. So that makes our dimensional model the victor, right? It's won that showdown. I mean, yes, it's the most flexible, but it's not best suited to doing everything. This is where mixed model arts comes in. So this phrase was coined by a guy called Joe Reese, who wrote a book called The Fundamentals of Data Engineering. The principles behind this is that you use the modeling approach for the use cases that you have. For most cases, you're probably going to be doing dimensional modeling, star schema in particular. For regulated industries where you might be obliged to track history and detailed lineage of each record that you kind of take through, Data Vault might be your friend. It's also then possible to feed a star schema with stuff from a vault. It's also possible to implement one big table or entity-centric from a star schema. And you do that because you might have the use cases for that. So if we look at this from a practical, conceptual perspective, we've got our incoming data sources from a disparate array of data. We could conform that into our data vault, then feed that into our dimensional model, and then we can then transform that down into our niche model areas. We could also just completely remove data vault. It's not necessary. Or we might want to take some of the concepts of data vault, like conforming concepts from disparate systems in a data vault-like approach before they're moving into a dimensional model. What these all display are various forms of specificity. So if your use case needs a high level of specificity, so very specific to use case, use one big table, producing a single output. If you need something quite generic, but on the flip side, you're going to have lots of entities associated with that, use vaults. If you need something in between, use something in between. So a lot of data models fail because they focus way too much on technical implementation rather than providing business value and meeting those business requirements. Analytics is fundamentally a collaborative exercise, and data modeling is a bridge between the technical and business users. When it comes to Agile, we mean delivering iterative incremental value, and the design that you start off with is not necessarily the one that you actually implement, mainly because things change. Organizations change, strategies change, requirements always change. Data models aren't static objects, they shouldn't be treated as such. In the infrastructure worlds, we kind of have this concept of cattle, not pets. The same could and should be applied to data models as well. Don't get attached to them, they will change, they will evolve. Sometimes you might just have to kill them off. The next section, we're going to can be applied to dimensional, entity-centric, or an OBT model. Can't really apply it to Vault. It's a bit special. But we have 3 different approaches to getting those requirements. Our first is Beam. Is anyone familiar with Beam? Okay, a couple of hands going up in the room. It stems from a book called Agile Data Warehouse Design by Lawrence Core, and that underpins the Beam approach. Beam stands for Business Event Analysis and Modeling. It's a process to capture the core requirements of a business event and to ensure that the correct measurements and values are captured. At its core comprises of 3 Ds and the 7 Ws, which are very cryptic at the moment, but we'll go into them next. So our 3 Ds, we discover an event. We describe the event using nouns, verbs, and adjectives, and then we document the event in a conceptual model. So the 7 Ws. We have who. Ooh. Who is the who within a given process. It's often going to be something like a customer or a client, but the actors could also be internal to the organization as well, like an employee or a salesperson. The what is the topic of the event. It could be products, could be services. The where is interesting, as a single business process could have multiple wheres. It could be where the center that the goods were sold from, where the goods will be dispatched to, or where the order is being sent to. Similarly with when, so importance around things like dates and times for a particular event, and again, might need repeating multiple times because there could be multiple whens associated with an event. So when an order was made, when an order was dispatched, and when an order was received. Why? There isn't always an obvious answer to this question. So in a sales situation, the why might be because there's a promotion, or maybe there's external factors like a snowstorm that then drove up the sales of snow shovels. How, again, might be challenging to answer because there might not always be a reason why an event exists. Back to our sales transaction context, it might refer to the commerce journey, as whether that's like a direct in-store or e-commerce. And then finally, how many? How many is where we define our facts, where we establish any quantitative values we want to capture. So like number of orders, profit margin, sales quantity. Using the 7 Ws, it encourages your stakeholders to start thinking about your business events in a dimensional manner, even if they're not necessarily familiar with the concept. Next, we have sun modeling. It is a word-of-mouth technique developed and taught by Mark Whitehorn. And at the heart of our sun model, we have our quantitative measures, which apply to a given business process. Given the example of a sales transaction process, we want to see the profit margin, unit quantity, and unit cost. From the central circle, we have our radials, which are our objects we want to slice and dice the data by. So these can correlate with our dimensions. And from out there, we're having our different spokes, which are our attributes that we want to further do things out. We can also straight line some of our attributes to represent hierarchies. So around dates, we've got like month, quarter, year. These are explicitly describing how we're going to handle our hierarchies. Another rule with some models is that every single dimension around the outsides must be able to slice and dice the measures in the middle. And if they can't, then we need to have another one. And the next one, Sunbeam, fuses the two together, takes the best of both. But it's also a bit more than just a data modeling approach as well. It is fundamentally a data product design framework that starts by looking at how an organizational strategy is constructed and then distills that down into a unit of value. We're not going to go into the details of how you kind of go strategy to model. We will touch upon some of that a little later, but not into the details, just because we won't have the time. But as mentioned, it is the fusion of the two. Fusion of sun, fusion of beam, takes the best from both, because they're both independently very good, but there are weaknesses to them. So with Beam, we start with an event identification, so discover an event. How do we actually do that? We do that with a timeline. We start with a timeline, and we ask, what is the most important event that happened within a process? So if we take the sales process as an example, we go, cool, customer buys products. That's our most important one. All right, what happens before that event? Well, customer might browse for a product. They might have multiple visits to our store. Okay, what happens after? Customer leaves a review. All right, what happens if that review is terrible? Well, the customer returns the product. So we've got different events that then need to be models. So if we take forward our customer buys product, it's always going to be described and defined by who does what. Sometimes it might be what does what, if we're talking about application to application. And like some modeling, our initial focus is going to be on the how many. And as we're drawing this out, we're documenting our conceptual model in real time with our audience. So start with a how many, do our who. Okay, what defines a customer? They have a name. Oop, they have a date of birth. They have a demographic group. And they have a gender. Is there anything else you want to know about a customer? Nope. Okay, cool, let's move on. Right, what did they do? They bought a product. What defines a product? Has a code, has a name, it has different attributes to describe what it is. Where did this happen? Right, had location. What defines location? It's got geo-coordinates, it's got physicality to it. When did this happen? Right, we've got a date, month, quarter, year we want to analyze our data by. Might have different calendars associated to this. Our why is that maybe there's a promotion on. Okay, what type of promotion was it? What does it look like? How is going to be our payment type in this context. What does that look like? Do they do it by cash, cards, pop it on finance? And then we have our 8th W, which is how often. And that's to really indicate the cadence of that business event. How often does it happen? How often is it captured and recorded? How often do we need to respond to changes? So regardless of which approach you take, they're all pretty similar. There are some tips and tricks. Ask the questions multiple times. There are going to be more than one answer for a lot of them. But for some, there might be no answer at all. However, if you are going down Sunbeam and you ask how often, you should, hopefully, only get one of them. Remember, one model per event, and don't get bogged down in what you already know about the data. Think about the concepts. Some of what might be fleshed out by users might be aspirational in nature. It might not exist in the data, but might need to exist, or it's been taken as part of a taken offline is like a manual process that they take out of the system, do an Excel, and then shove somewhere else. That's something that you need to consider, make recommendations for automation. But without asking questions, you're never going to find these things out. Remember, it isn't a fixed or finished design. It is a target and probably will change during implementation. Reminder of 3Ds, you discover an event, so who does what, describe an event using the 8 Ws, and document the event in a conceptual model using a sun modeling technique. We can also be more efficient with our modeling approaches. 50% of a data model can be reused. Any authority on modeling will have written about generic patterns that can be used. So things like currency conversion, ragged hierarchies, history tracking, and slowly changing dimensions. If you've worked with many businesses in the same industry or across similar industries, you'll probably notice very similar behavior in processes. So if we think about like working with finance teams, for example, the requirements for general ledgers are very similar, and there's an opportunity to reuse patterns you might have come across before. But what makes an organization unique are the things that make it deviate from the norm, or where you need to accommodate for the quirks of the organization itself. Ultimately, every company is a data company that just happens to do something that differentiates itself from other data companies. So we can reduce overall effort by reusing the efforts of other people, like Kimball. We can recycle patterns that we might have seen before, and then everything else is then organic effort we need to put in. All right, at the beginning, we mentioned that data modeling has become popular again. Woohoo! And that's due to data mesh. But more importantly, it's become important because of things like data products. But what is a data product, and where do data models fit into it? So if you think about a product in general, a product has customers. If there isn't a clear customer base, why does it exist? It needs to have usability and a user experience at its forefront. So its design and implementation, it needs to be feasible with the skills and technology that you have or potentially will have. And it needs to be viable. It shouldn't cost the earth. It shouldn't cause legal or ethical issues. And it shouldn't really damage the reputation of a company. There are lots of definitions about what a data product is, whether it's a product enabled by data or data as a product. We subscribe to the latter, it's data as a product. So we need to start treating it as a product. It is an encapsulated unit of business value with all the attributes of a product that we've seen previously. Essentially, it's one or more tables that can be queried, providing curated, trusted insights into a specific area of the business. So if we take our dimensional model, if we kind of extrapolate that into a technical aspect, we're curating some data, we're popping a query layer over the top, and then providing interfaces for reporting and analysis. The product itself is the data, but we're providing many avenues for users to query and interface with the data. If we take one big table, it's going to look very similar, but our end reporting tool might be different. It might be Tableau. Similarly, with entity-centric, going to be a similar approach, just again, the different tools which we're using for a different use case. So we're modeling again for our use cases that we have. For a data product to be valuable, an easy way to do that is to align with a company strategy. Most strategies can be boiled down to increasing revenue, reducing costs, in order to maximize profit. Woohoo! But we want to do these things so that there's always an impact. So we're increasing revenue through some initiative so that there's an impact. We're reducing costs through an initiative so that there's another impact. We're maximizing profit so that the company can be more, it can do more. So if we use the Purple Chocolate Company as an example, I'm a big fan of the Purple Chocolate Company. Don't get enough of it in France. We can increase our revenue by raising the price of the products to our customers so that we can do something nice. We can pay our farmers more. We can reduce the costs by making our bar smaller so that we can maintain our manufacturing costs. This is shrinkflation. If everyone was only so good. And we can maximize our profits so that we can do something amazing for the world. We can invest in a sustainable manufacturing plant. If only the real Purple Chocolate Company was as good. So we've got the what, we got the why, and we got the how. When it comes to data products, we've got our more operational aspects to our data. We want to increase revenue, we want to reduce costs. So our products could be around being direct to consumer, our wholesalers, maybe our retail partners. And our audience is going to be sales, might be marketing. On the cost reduction side, we'll have our farms, have our manufacturing plants, and we'll have our warehouse and distribution systems. And our audience is going to be our suppliers. It could be our stock keeping teams as well. They're going to be thinking things very operationally, even if the insights and analytics you're giving them is quite strategic at the same time. But if we're saying that each product by itself provides value, if we combine at least 2 data products, maybe we get something different. Maybe we get some compound value. So our data is going to be sitting in the different data products. They can be used and abused by other products. So we can take in from our other systems into our more strategic view. We're resharing the code base, we're resharing the data, but we could also be amalgamating that data, enriching it, aggregating it as well. So we can have very, very different types of products. Product retirement. Are there any products that aren't selling that well? Do we have a lot in stock? What if we discounted those products? What would the impact of sales and revenue be if we discounted particular products? What would the impact be on our warehousing teams? Would we need to change shift patterns? Would we need to hire more seasonal staff? And what impact does that all have on profitability? What can we do to maximize that profitability? So we can achieve a more compound value by providing a broader, potentially more impactful and valuable path for analysis. So again, we're shifting from a more operational view to a more strategic view of how we use data. But because a data product is supported by a data model, using something like Sunbeam is going to produce that design for a data product, regardless of what form that takes, whether it's dimensional model, one big table, or entity-centric. Translating that data model into an end product is a matter of applying the use case and the product attributes to that design. So we've got our model. Now I want to start interrogating it, asking questions of it, finding out what our partners in the business can find of interest to them from an analytical perspective. So we start asking questions, creates a set of user questions. So as a sales director, I want to answer, what products makes us the most profit? What are our net revenue sales for last month, and how does that compare to a previous period? Do our stores have enough inventory for the next month of forecasted sales? So we've got these questions, we can start prioritizing them. We can start looking at the dependencies that we might have between them, so we can start answering them, and we can translate them into user stories so we can start delivering iteratively. So that when it comes to implementation, we're starting to provide very early return on any investment made. But we all want our insights to be actionable, whether that's through behavior change or automated decisioning. KPIs, key performance indicators, are a great way of doing that, and that allows user questions to provide action. Allows us to start telling stories with our data. And aspects like data models, there will be industry standard definitions that can and should be applied before creating any organizational specific ones. But beyond KPIs, there are scenarios. And these scenarios can be applied to user questions. So for example, do we have enough stock? Our scenarios could be, what happens if there is not enough inventory? What happens if the stock check has not been conducted? What happens if the stock data has not been refreshed? I mean, if all these things happen, it's a perfect storm, it's going to be carnage. But user questions, KPIs, scenarios all form the basis of designs for reports and dashboards. But not all actions need to have human intervention. They could be an automation off the back of this, like fulfilling a stock fulfillment request. So as part of your designing solution, you need to just have a conversation with users to find out what they would do in the event of those types of scenarios. So we've got a lot of theory. How do we go about turning a concept into reality? So we've got our conceptual model that we've designed using Sunbeam in Miro. You can use any physical or virtual whiteboard available. We then go through the user question process and gather a list of questions. So what products make us most profits? What are the net revenue sales? Sales forecasts, which products perform best? Which locations perform best? So we've got the list of questions, and then we can start prioritizing them. We can prioritize them according to what best supports our strategic needs. So in this example, we can tactically forecast sales before moving on to location. And what was the first written down user question has been deprioritized, because there are more important things to focus on. There's higher priorities that we need to achieve. We can then isolate what needs building first, including any aspects which we might be missing. So in our second example, we don't even need to create the full dimension. Our interest is really only on narrow aspects of the location. In our third example, we don't need to add any new dimensionality, but we do need to introduce new metrics. And our fourth, adding a new dimension. And by our fifth, we're adding new metrics again. So we're now delivering iteratively. We're delivering what is of most value first and improving from there. What is there conceptually, so customer orders product, might not be productionized for a long time. So despite that conceptual event being customer buys product, the strategic need in this example doesn't even focus on customer. It's all about the product. So there's no need to deliver everything all at once. And as long as you're continuously delivering value to your customers, you're in the mindset of product thinking. So there are lots and lots of things to read. Better in the PDF, which you'll find, I think, on the link on the speaker profile. And you can download or have a look at some of these objects. So thank you all very much for giving your time. Thank you to the volunteers, organisers and sponsors for making SQLBits happen. Reminder of feedback and questions. Yep.
I still find myself often in projects where you don't apply data mesh. You still build a data lake with, a concept called.
Hold on. There's a microphone coming.
Yeah, so you talked about the data mesh, but I find myself often still in projects where we build a centralized data platform, where we do build a data lake with a medallion structure, but where the gold layer or the endpoint is not per definition a dimensional model, for example, because a data warehouse can be just one of the outputs for your platform. So how would you go about modeling like that layer? Maybe it's like an operational data store kind of concept, where you do want to implement your organizational data model, but how would you go about making the translation and modeling that part of your data platform?
Yeah. So it's going to go up. Sorry, going to go all the way back to this bit. Okay. So there's no need to employ mesh if you don't want to, because it's not going to suit most organizations. It requires a significant organizational maturity that most organizations don't have, unless you are a digital native, and even then, you still might not have that. So we still model based upon our business events, our business processes that happen. So, like, if we're thinking about a traditional dimensional model, we have our sales order fact, and that is going to be comprised of our customer buys product event. And all we're doing is really just applying that product mindset to that same traditional process that we're doing and have done for decades now. But because we're treating it with respect, we're providing value to it, we're also thinking about the life cycle of that product as well. So the modeling aspect's probably not going to be any different from what you might already be doing. It's just changing the mindset of how you start deploying and interacting with that data itself. Has that answered your question? Cool. Anything else? Could you repeat with the mic?
Do you like Data Vault?
Do I like Data Vault? No. No, I do not like Data Vault. It's too formulaic. It's too rigid. It has a purpose, and the purpose is very narrow. Which, yeah, it's a tricky one because it is still also a valid modeling approach. I just don't like it.
Could you elaborate further on one big table approach? I personally found myself using it more and more for self-serve analytics and to optimize performance of Power BI, for example. What are your experiences, your thoughts?
Yeah, so with Power BI and one big table, I wouldn't use one big table at all because Power BI is optimized for a star schema. One big table is going to be where you do want to do self-service, but it might be from like a SQL aspect or an API endpoint, or it might be because the reporting tool that you've chosen is Tableau or Looker or something that expects a single table. Again, it's always going to come down to what do you have available, what are the skill sets of the people that you have before they're making the decision as to, right, what tools do I need to implement, what approach do I need to take. So there's a time and a place for one big table, and it's more going to be around how are people interacting with data rather than what tools it's necessarily going into.
Hi there. Hi. Well, you've hit my buttons about Data Vault because I'm a big Data Vault fan.
Oh, I'm sorry. We can still be friends.
Well, agree to disagree, but the thing is that Data Vault is not meant, like you at the beginning showed, it's not meant to be queried directly by the reporting layers.
Yeah.
Data Vault is following Inmon, is an intermediate layer, enterprise data warehouse, that you extract the dimensional model from it. So of course, there is a price to pay for all the joins. So the reason why there are so many joins on Data Vault is because it's an integration layer. So you are storing data independently. Well, and one extra advantage is that you can load data concurrently and in parallel on Data Vault. So that's something you cannot do in a normal relational model, third normal form. So here I am defending the Data Vault flag.
No, that's perfectly okay. And you are right. It is an integration layer, but it does get used and abused often. It gets used as a replacement for a warehouse. No, you are right. All right. If there's nothing else, I think it's almost time. Cool. Thank you very much, everyone.